Hello and welcome back. Uh, as you may remember in the previous video, we explained about two different ways that we can penalize the variables that we have in our model. As we explained, the process of penalizing the model is called regularization, and this process of regularization is helpful to fix the issue of overfitting. Here we have one example. I want to explain that how these two different regularization, means LASSO regularization and rigid regularization, can be implemented on skitlearn. We are using the data set, which is some features about housing in California and price, and the goal is to fit a model to use some of these features and predict the predict the price. Again, we will use the same method for importing the file of data, CSV file of data into Google Colab. I will post these CSV file again on Carmen. For some of you who wants to practice this more, please use it. And here we can see some features that we have in these data. So that we can see price is one feature, and the goal is to predict price. We have other features like bedrooms, bathrooms, floors, square feet lots, and some other features related to the house. We will consider one subset of these features. As you can see, the subset that I consider is price, square feet living room, square feet lot, bathroom, bedroom, and grade. These are some features that I consider. And here we can see this data frame. For example, if we consider the whole data set on this subset of features that we consider, we can have such a data frame like this. Then here you can see price is the first column, and we have some other columns, and the goal is to use these features and predict price. Then here I define two subsets. One of them is predictors. Predictors consist of these features that we want to consider for our model, and outcome, which is price, and the goal, as I explained several times, is to predict price. So now my goal is to fit a linear model on these features. As we did before, for previous example that we had in other videos, we use a linear model from the first dimension because we had just one feature, X. In this case, as you can see, the number of features are more than one. Then here we have multi-variable linear model. Then again, from skitlearn, we will call linear regression. In this case, as you can see, you do not need to write linear regression. You do not need to add a skitlearn here because skitlearn already is imported. And as we explained, this linear regression is inside one sub-library of skitlearn, that sub-library linear models. All of them are already imported, then you can use it and you don't need to import one more time. Then here we have linear regression. We name this model house LM stands for linear model. And then, as we explained before, after defining the model, you will fit the model by using the keyword .fit. Here, since linear regression is the example of the supervised learning, therefore features and labels both should be given to the model. These are features, and this one is the labeling. Then the linear model will be trained. So in this case, as you can see, the number of features that we have is 1, 2, 3, 4, 5. Therefore, we have more than one coefficients. Then the coefficients or that we learn are here. Then, as you can see, we have one intercept and we have 1, 2, 3, 4, 5 coefficients. Okay, then after training this model, as we explained, R-square is one statistical invariant which can be used to evaluate our model. As we explained also before, the loss function that we can use can be mean square error, MSE. Then these metrics, which are a statistical metric, which can be used for evaluating the model, can be imported to the Google Colab, and it can be used. Then again, from skitlearn, we can import these features. As you can see, how much skitlearn is helpful package for doing data science and machine learning. Again, from skitlearn, we will import mean square error, but mean square error also belongs to one sub-library of skitlearn. That sub-library is metric. Then from skitlearn.metric, we will import mean square error. And again, from skitlearn.metric, we will import r squared error. And in this case, we can consider the prediction. If you want to consider the prediction, as we explained this before, predict is one keyword which can be used. Then the model that you define here is house /lm. That's a model that we train here. And by fitting, we fit the model, we train the model. Then here, when we want to use the prediction, we use .predict. And a set of predictors should be given. Here we are using the set of prediction that we use for training, but in general, you use another set of predictions. Okay, then here we are defining mean square error that we imported here on the value that we fitted here. As you can see, the fitted value are the values which are estimated by the model, and these are the actual value. Then we compare the actual value and estimated value. Actual value are the price which are actually given. This fitted value that we are estimating here is the price that we estimate by these features. The mean square error can give us the sum that we explained about, but here in this case, as you can see, because the value that we get can be positive, then here we are taking the square of this value. And this is for r squared. And again, as you can see, for r squared, we are giving the actual value for the price and the value that we have estimated for the price. So these are the values that we can get. As you can see, for error, the value that we get for mean square error, the value that we get is this one. And for r squared, we will get this value. As you can see, these are not very good values because the model that we fitted here is not very appropriate, but it can give us the sense that how these metrics can be evaluated in skitlearn. Okay, so we can also continue on this data set and see more about these. As I explained, when we want to evaluate the performance of model, it is not good to consider the same data set as training and testing. Therefore, people prefer to split their data set into two subsets. One subset is considered for testing, one subset is considered for splitting. It can be done manually on Python, but also it can be done by using a skitlearn, which is much faster. The way that we can do for skitlearn is using one tool that we have, which is train test split. If we want to find train test split, again, it should be imported from skitlearn. And when we want to import, again, it belongs to one sub library of skitlearn. We can, by using the keyword from skitlearn.model selection, we can import train testing split. What train testing split does, you just need to assign the size of the testing set, and then this tool automatically split your data set into two subsets. Here in this case, as you can see, I assigned the size of testing set 30%. Then 30% of the data set is considered for testing. 70% will be considered for training. And here data is given. And again, as we explained about seed in another video, the reason that we use random state because this splitting is done randomly. And since we do not want to get the different the data set every time that we run this, then we use this line of code, random state equal 42. Any number can be written here, not necessarily 42. Tells the Python that next time that we run this, use the same data set. So then here, for example, we can see a data frame for train part. And here, as you can see, that's a data frame for train. Okay, we are ready to use this data set for, again, linear regression purposes. Then again, from Skyline, we will import a linear model. It is not necessary because we have already did it, but I think it is helpful to explain this here for future. When you want to use this line, it means that every time that you need linear regression, you do not need to write from a skyline.linear model import linear regression. When you write from a skyline import linear model, every time that you need linear regression, you just need to write that the name of the model that you want to use. Then in this case, as you can see here, I am importing linear model here. Then since linear regression belongs to the library of linear model, then every time that we need linear regression, we just need to write the name of the linear regression. But here in this case, we do not want to use linear regression. In this case, our goal is to use LASSO and rigid regularization that we learned before. So I will split my data set into two, training and testing. And here the training that we consider will be considered on the predictor and outcome, because the data set that we have consists of more features. But we want just to consider sub data set, which consists of the features that we define as predictor. You know, here we define features as predictor, these features which are considered as a predictor. Our goal is to consider the sub data set on these features, and outcome the same. Outcome here is the price. And now we are ready to train a linear model with LASSO regularization. Then this is one tool that we have inside linear model. You just need to write this linear model dot LASSO. And as we explained, there is one constant for LASSO and rigid model. Then here I am assigning one value for that constant for LASSO, that is denoted in the slide also by alpha. Alpha here is 0.1. And here by adjusting this 0.1, you can get the different values. And when we train it here, as you can see, we are writing the same name of the model, dot fit, with the training data set. Then here one LASSO model is trained. So the coefficients which are estimated, which are learned, can be seen here. And the intercept which is learned also can be seen here. We have the same tool for rigid. And for rigid, if we want to use this again from intentionally, I showed you two different ways that this code can be done. Sometimes you will write from a skitlearn import the linear model. Sometimes you are using the dot notation. If you write from a skitlearn dot linear model, then the name of rigid should be imported. As you can see here, we have rigid. As you can see, the difference that we have here, when you do not import LASSO here, then this linear model should be written, because this LASSO belongs to this sub package. Therefore, linear model should be written, then dot LASSO. But in this case, as you can see, since I import rigid here, therefore I do not need to write linear model dot rigid. As you can see, just rigid is enough. I am defining rigid model, rigid, and here the constant of rigid function is assigned 0.2. Again, any number can be considered here. Again, we are using the same method, means the keyword fit will be used. And again, we are using the training label and training feature. And then the rigid model will be fitted. So if we want to see the performance of the model that we have trained, we can use again RMSP, RMSE and R squared. Then again, in this case, for example, we are considering the rigid model that we have trained here. We are using the predict. In this case, as you can see, instead of using the training data set, I am using the testing data set. This is something that people do a lot in machine learning models. It means that we prefer not to use the same data set for training and testing. In this case, as you can see, we are using the testing data set for evaluating the performance of the model. Okay, again, we will do the same thing. The mean square error that we have imported will be used here. We are taking the square root of these. And in this case, again, R squared, which has been imported, also will be used here. Then by running this, as you can see, you will get the R squared and RMSP value, RMSE values for this model. Okay, thank you for watching. I think it is a good time to stop.